Welcome to lecture series on design and analysis of algorithm. In today's lecture, we are going to see another problem solving technique and dynamic programming called as computing binomial coefficient. The knowledge about how to compute binomial coefficient is very much essential for solving optimal binary search tree problem that we have seen in the later part that we will be seeing in the later part of this lecture. So let's have a quick recall on the topics we have seen earlier. Like we have seen what is algorithmic problem solving technique, the important problem types, followed by problems that are solved using brute force approach. We have also seen what is divide and conquer technique and the problems that can be solved using divide and conquer technique. So today's discussion is all about dynamic programming approach, its characteristics, components, and the principle of optimality followed by calculating binomial coefficient. So here, look at these two figures. Have you identified the difference between these two figures? Sorry. So have you identified the difference between these two figures? Is so when you see the first figure looks static, whereas the second figure looks dynamic. So now look at this graph. What do you observe from the given picture? You want to reach the goal node from start node. So between start node and goal node, you are having several intermediate nodes. So all these intermediate, if we take the problem as reaching the goal node from starting node, the intermediate nodes are considered as subproblems. So here, these are the various kind of problems. If you want to solve them using dynamic programming approach, you will use mathematical formulas. These mathematical formulas are used to find the optimal solution. Now, this defines what a dynamic programming approach is all about. It is one of the most powerful technique for solving any kind of optimization problem. If there is a problem with overlapping subproblems, yes, dynamic programming is the best choice. uh, if you if you recall what we have discussed during divide and conquer technique does not have any overlapping subproblems. However, problems that are solved using dynamic programming has overlapping subproblems. So this approach stores a result of any subproblem that is solved once for future reuse. This technique of storing the results of the subproblem is called as memorization technique, which is used in dynamic programming. So the main characteristics of dynamic programming is it has optimal substructure and it has overlapping subproblems. The elements of dynamic programming is it has substructure, table structure, and computation. Here are the components of dynamic programming. It is solved in various stages. Like it 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 involves various stages before finding a solution, and there are various states involved. And it chooses a decision. It takes a decision and to find the optimal policy. So here is a major difference between divide and conquer technique and dynamic programming. As I have said earlier, divide and conquer is used to solve subproblems. However, the subproblems are not overlapping, whereas in case of dynamic programming, the subproblems are overlapping. That is, they are interdependent. Whereas in case of divide and conquer, they are independent of each other. And it can be used for solving recursive algorithms, whereas dynamic programming can be used for solving non-recursive problems. So some of the example problems that can be solved using divide and conquer is merge sort and quick sort, and that can be solved using dynamic programming involves optimal binary search tree and matrix chain multiplication problems. So initially you have to characterize the structure of any optimal solution, and you will recursively find the value of the optimal solution. Uh, Once you calculate the value of the optimal solution from bottom up, that is from starting from the smallest subproblem, you will construct the optimal solution for the entire problem based on the solution of the subproblems. Here are some of the applications of dynamic programming. It is used to solve 0-1 abstract problem. It is used for finding all pair shortest path problem. It is used to find the longest common subsequence, and it is used in time sharing problems. So here is the principle of optimality. A problem is set to satisfy the principle of optimality if the subsolutions of an optimal solution of the problem is the optimal solution itself. This is called as principle of optimality. So let us see how to calculate the binomial coefficient. So the formula to calculate binomial coefficient is C of n comma k equal to C of n comma 0 into a power n plus C of n comma 1 into a power 1, which continues till C of n comma n into b power n. So if you want to calculate the binomial coefficient of 7 comma 3, so the formula is 7 factorial divided by 3 factorial into 7 minus 3 factorial. That is, if you want to calculate binomial coefficient of C of a comma b, the formula is a factorial divided by b factorial into a minus b factorial. So that gives the binomial coefficient of these two numbers. So by using this table structure also we can calculate the binomial coefficient. So this is a formula that we have seen earlier. This recursive relation is used to calculate the binomial coefficient of two numbers. So the cost of the algorithm is filling out the table. So the time taken to fill the entire table is the time complexity of the given algorithm in addition to the basic operation. So the sum needs to be split into two parts because only the half of the table needs to be filled for I less than k and remaining part of the table filled out across the entire row. So here are some of the assessment questions for you to have better understanding on what is dynamic programming and what is binomial coefficient and principle of optimality. Please go through them. Hope you have understood what is binomial coefficient and how to calculate it, and what is principle of optimality. In the next lecture video, we will see how this binomial coefficient is used in constructing the optimal binary search tree. So this is a mind map of the entire topic we have discussed so far. Thanks for watching.